everyone, I'm very happy that you have come to my session about performance testing with Autocannon. But first, before we will really go into some technical stuff, I would like to introduce myself. So I am Tamar. I'm writing code for a lot of years, and it's my passion to write code. In addition to that, I was managing large development groups, and I was working as an architect in several places. Currently, I lead the backend development in a startup called XM Cyber. It's a really cool startup. What we're doing is we're imitating the activity of a hacker in a computer network. In addition to that, well, I'm an expert in Node.js. And my interest in Node.js had started when I founded my own startup and I wrote my entire backend with Node.js. At that point, I really fell in love with that technology, and I started to investigate it and start to understand the deeper parts of it. And from that point, I was really focusing on that technology, and it's definitely my favorite. You can follow me on Twitter, and you can find previous lectures of mine in YouTube. In addition to that, I have 3 kids. I'm a professional violin player as well, and I'm a community leader in JavaScript Israel community. We organize really cool lines of meetups. So if you happen to be around, and in Israel, and you encounter a meetup of JavaScript Israel, then it's really nice to be there. It's recommended. Okay, so now let's go into the technical part of the lecture. And I would like to talk a little bit about the mystery of performance testing. Why do I call it mystery? Because let's say that at the first time that I did performance testing, I felt like I was climbing on a mountain. Well, it was very, very hard and confusing. So why it was very hard and confusing? Because I had so many questions, because everybody was talking a lot about a lot of terminology that I did not understand. So to which terminology I mean? Well, when you're doing performance testing, you're talking about a lot of terms and a lot of measurements that you're not familiar with, and at least for me at the beginning left me a little bit confused. So first of all, the throughput of the server. So how do you measure this throughput of the server? What does that mean? I mean, I can simulate a lot of scenarios in a lot of ways. So what is the best way to what is the best way to measure the throughput of the server? In addition to that, concurrent users. Concurrent users, how would that affect my scale? What is it? I mean, what is a concurrent users? What does that mean? What is that measurement? How to simulate that? What is the difference between that and between HTTP pipeline? Another thing that is very common when you're talking about performance testing and talking about benchmarking is the 99th percentile. What is the 99th percentile? Why it's very important? Because sometimes when I measure and when people measure, we're looking at the 99th percentile much more than what we're looking at the average. So why the 99th percentile is so important? And the last thing is the average response time, or the response time. So the response time, how you measure it, whether you have to look at the average or the 99th percentile. There's also the standard deviation of the benchmark that needs to be taken into account. So all of those, when you first encountered them, left me very confused. And I had to understand exactly what I'm doing in order to understand how to simulate my server in order for it to the test means something and really improve my performance. So let's explain a little bit about all those terms and just a little bit in a high level to like get you in order to all of this. So first of all, of course, the main goal for performance testing is to understand how much load our server can handle. Well, usually you're working with one Docker container, to my opinion, in performance testing, and then you're like simulating HTTP requests to that like one Docker in order to understand what throughput this one Docker can handle. And if this one container can handle 100 concurrent requests, when you duplicate it and you create another instance of it, you create another replica, then you're able to handle 200 requests, etc. If you create 3 replicas and 300 requests, but it's really important to understand how much load one Docker container actually can handle. So important question that was needed to ask. So what is the 99th percentile of our response time? And what is the throughput? How many concurrent requests can we handle on average? I mean, those are like very important questions. And why those questions are important? First of all, the 99th percentile of the response time. And in performance testing, it's really important to look at the 99th percentile. And the question is why it is important to talk and look about the 99th percentile. Why the 99th percentile is so important. So imagine that you have a commitment for a third party, meaning that somebody is using your system and you're telling them, listen, my requests are always faster than, let's say, 3 seconds. If you would go on the average, then it's not a data that you can rely on. And why it's not something that you can rely on? Because you have standard deviation. Usually, most of your instances are not around the average. You can have like instances that are far from the average. And in that case, it is better to look at the 99th percentile, because that means if it's 3 seconds, it means that 99% of my requests were faster than 3 seconds, and only one request, only 1% was slower than 3 seconds. Yeah, this is why. And then you're very sure to give a commitment. You feel confident in that commitment to a third party to say, hey, yeah, this is something that I can rely on. My requests are faster than 3 seconds because my 99th percentile is 3 seconds. So this is why this is important. Another thing, and this is, I think, the most valuable measurement in order to understand the throughput of your server, is the average concurrent requests. What is the amount of concurrent requests that can be run simultaneously? Here we're looking at the average and not on like the 99th percentile, because in some cases, or most of the cases, the 99 percentiles represent a peak. Because when you have a peak, then your server can like have more. And the maximum concurrent request is like your throughput during a peak. But that is also a really important measurement. All right, so after we're speaking about all of that, let's speak about Autocannon and how Autocannon is getting into the picture. So you need to have like a tool that can simulate requests. I'm talking about sending a lot of requests simultaneously. So you need something that will help you send those requests simultaneously. You need to control the amount of concurrent users. You would like to control the runtime. I mean, you want it to Like you want the tool to be run for 15 minutes or 30 minutes for a period of time. And that is how Autocannon is getting into the picture as a really good tool to simulate performance testing and do benchmarking. So what is Autocannon? So Autocannon is a tool for performance testing and a tool for benchmarking. It is written in Node.js, which is really cool, like that it's written in the language. And it's supporting HTTP pipelining for HTTP. It's supporting HTTPS. It supports concurrent connections. But yeah, I'm talking about HTTP pipelines and I'm talking about concurrent connections. And you know what? Let's talk about what are HTTP pipelines and what are concurrent connections and what is the difference between them. So HTTP pipelining, meaning that I'm sending, well, the diagram is in the left side of this screen. HTTP pipeline, meaning that I'm sending 3 requests, and I don't have to wait like for the first one to return and then send the second one, but I'm sending them simultaneously. I'm sending them without waiting for the response. So here in the left side of the picture, I'm sending 3 requests without waiting for response. Then on the right side, we have concurrent connections. Well, what does it mean? It means that we have a socket open from the client to server, and you have requests on that socket, but that is a simulation, a good simulation of users, for example, approaching your website. Because if you have like 1,000 users approaching to your website, you have 1,000 concurrent connections. So that is what I can say. How do you install the Autocannon itself? First of all, if you want to install it in the command line and use it from the command line, I specifically really like to use it from the command line. You can do npm install Autocannon and then install it globally with -g. And then you would have like the command line tool of the Autocannon. If you want to use this API from your JavaScript code, then you can do, it's like installing a library for a JavaScript project that you write. For example, for Node.js, you do --save in order for that like library notion to be part of your package.json. So you can definitely do npm install Autocannon -save. By the way, to my opinion, I think that you need to install it with save dev and not with save because it's development tool. But now, after we spoke about it, I would like to show you a cool demo about testing a server with Autocannon, and then we will show the improved version of the server and try to compare some results. Alright then. Cool. So, let's look at this nice server code. Okay, so this is a server code that we have. And I hope that you're all familiar with Express. Express is a library, it's an extremely popular library for hosting and publishing HTTP APIs for your servers. The syntax is really clear. Here you're requiring Express, you're exposing it on specific port, on my case 3000. Here you're exposing a route. This is called an express route. I'm exposing one simple route of get with a slash. It would be an HTTP get. What this route is doing, well, you have a hash function here. This is hashing a password. I gave it like a password which is a constant here, random password as you can see. But, well, when you enter here, you have this function. It was doing an algorithm in cryptography. It's generating a hash to this string that I has transferred to it using a salt, a random salt. This algorithm is what's called CPU intensive, but worse than that, it's synchronous. If you're looking at here, I'm using it in a synchronous API of Node.js. There is no callback promises or anything like that here, which means that it would be executed inside the event loop itself. And it would cause like a freeze in my code. So let's try to test this server a little bit with Autocannon and test the results. All right then, so this is the command line. And I think the instance of the server is here. Let's take it down and let's run it. Yeah, here it is, up and running. Server is up on 3000. And then let's do Autocannon. Which parameters I give it? C, it's the number of concurrent connections. D, as you can see, is the duration, and W is the workers. So right now I don't want to give it workers. I would like it to work with -C, -D. Let's hit enter. Now let's count till 10. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, cool, we have the results. Okay, let's see what we have here. So first of all, let's look about the latency. Here's the latency of that run, meaning the response time. So the 99th percentile is 1.5 seconds, meaning that 99% of my requests were faster than 1.5 seconds, and 1% was slower than 1.5 seconds. As you can see, the average was close to 800 milliseconds, and the standard deviation is 180 milliseconds. The maximum request is around 1.5 seconds. So this is the data that we have here. Let's remember it. 1.5 is the 99th percentile. Then we're looking at how many requests per second. So we can see that on average, we were handling 12 requests per second, but at most we were handling 13 requests per second. We never handled less than 10 requests per second. So as we can see, our NAS server can handle 10 requests per second. Now, after doing that, let's stop this server and let's see the other server that I wanted to show you. All right, so sorry, let's go to VS Code. I didn't want to go back to my presentation, but yeah, you can see here, this is the second server. This is also implemented in Express, a simple Express server, very simple, and it exposed the same API, but here we are working with the Asynchronous API. As you can see, it's right here. So how do you know that it's asynchronous? Here there is a callback that is being transferred and resolving it, meaning that this is not a synchronous operation anymore, but asynchronous, and is transferred to the event loop. It's transferred to the worker thread and is not blocking my event loop. So this is what we can say about that operation. So now, after we've seen that, let's go to the command line and, well, first of all, let's find the server that we had. Sorry about that. And as we said, this is the server. Now I'm running the asynchronous version of the server that should be more efficient. And let's look at the results now. Okay, we're running it for 10 seconds, remember? 1, 2, 3, 4, 5, 6, 7, 8. All right, let's see what's going on here. First of all, the 99th percentile is 1.4 seconds, which is much better than what we have in almost 100 milliseconds. So it's better. The next thing is the average, which is close to 700 milliseconds. And if you remember, the previous average was around 700 milliseconds, which is good. Then let's look at how many responses we can handle So the average, if you remember, was around 12 requests per second. So the average went up to 14 requests per second. And the 99th percentile is 20 requests per second, meaning that in peak, we can handle 20 requests simultaneously, which is in contrast to the last run that, like, the 97th percentile was 14 requests per second. So yeah, we can see that all of the measurements has been improved, which is good. But this is like a standard run of Autocannon, and this is how I can see the results and I can analyze them. And this is a process of, well, here I had a server and I knew what was the problem in advance, but you can do this process and change your server and then rerun it and run Autocannon and look at those measurements, like basic measurements, and see whether there are improvements. All right, cool. So now let's go back to our presentation, to my presentation, and let's continue Autocannon. One thing that I would like to say about Autocannon, which is pretty cool, which is, well, Autocannon actually uses worker threads. I hope that you're familiar with worker threads. It's a cool module that is implemented in, it started in Node 10. Right now it's implemented in, it's become non-experimental in Node 12. And it's enable us to run several event loop in parallel. And, well, this module is well, it is used here in Autocannon, which is really cool. So if you want to work with several workers, you're able to do that with a flag of -w. All right, so let's start integrating Autocannon with our JavaScript code. First of all, the basic example. So my main goal is to, like, write testing tools, cool testing tools that can help me test my application. So here is a basic example. We're getting an instance of Autocannon, and then look what we're doing. We're just starting the run. At the end of the run, we're printing it. Here I have 10 concurrent connections. I don't do HTTP pipelining, meaning that it works in a way that he send a request and wait for a response before he would send another request. And the duration here is 10 seconds. And this is how you can simulate. Another example with async await. Well, most of us are working with async await in, like, modern code of Node.js. Here, async await, you're creating an instance and you're waiting for it to finish the run, and then you print the results. Another nice thing that you can do in your code with Autocannon is it has an API of client events, meaning that you can receive an event and do something with it. For example, every time that you receive a specific response, you can handle it in which way that you want, which can be useful. So this is another API that it's really nice to explore. And the last thing, well, usually when you want to do performance testing, you don't want to send the same request all the time. You would like to have variety of requests. And here is where the feature of Autocannon with requests help us in coming into an action. So here you can see in the example, we have two requests. The first one is a post request. And what we're doing here is we're posting a product, and then we're getting the ID at the response that the server has generated for us. And then for that product, we are posting a catalog in the second request. So in the first request, this is the flow, we're posting an ID. We're posting a product. The server is generating an ID. And then on the second request, we can take the ID and post more data for it. So this is a flow that can give you variety and flow and multiple requests And this is more close to simulate like real life scenarios. This is more close to that. All right, so we are really close to the end. So just like really small tips for testing production scenarios. First of all, a thing that, at the beginning I wasn't aware of, and when I become aware of, it has improved my performance testing very much. You have to make sure that the data that you're testing on is similar to what you have in production. Meaning that, if a collection in a specific size, make sure that your mock data that you're testing with it is also in the same size. That fields in production are identical to fields that happened in your database, that appear in your database. And look at your production flows and try to mock them as much as you can. That was it. I hope that my lecture gave you some knowledge about performance testing, and I hope that Autocannon, you would explore it a little bit in order to try to write your own performance testing tests. So that was me. That's my Twitter handle. And thank you very much for listening.